calculate the electric flux through a sphere. So in this case, I have considered two parts. One is we will find the electric flux through a sphere due to a point charge or the flux passing through a ball, because ball is a sphere, when the point charge is on the axis of the sphere, right? So this is a sphere or a spherical ball of radius r with center O, and this is the axis of the sphere, and here I have taken a point charge q, right? Now I have to find what is the flux passing through the ball, right? So we have to take into consideration here, we have to find electric flux passing through the ball. We need not to calculate electric flux coming through the ball, because coming through the ball is how much flux is passing here and how much it is coming here, right? So that will be the same case. So the flux coming in is flux going out. Now this is the charge here, so the electric field lines will be emanated in all the directions. The field lines will be tangentially touching the sphere here at this point and at this point, and these 2 points are not diametrically opposite points, because the diametrically opposite points are here, right? So they will pass through the center. So that means the disk formed here between these 2 points will not be of radius r, that will be of different radius, right? So we will use here a different approach then. So what we do, if we, for example, say that alpha is the semi-vertex angle subtended at the charge q by these two tangential field lines, right? Then phi is equal to q divided by epsilon naught, the solid angle subtended here, so that is omega, then divided by 4 pi, right? So this is the general formula. So that is given by phi is equal to q divided by epsilon naught. The solid angle subtended by the semi-vertex angle alpha here is 2 pi 1 minus cos of alpha divided by 4 pi. So pi and pi will cancel. So this is 2 1s are 2 2s are, right? Now, what will be this side here equal? If this is r, the distance from the center to the charge is r, the distance, or we can say the radius of the sphere is r, then using the geometry here, we can calculate this is under root of r square minus r square, because this is base, this is perpendicular, and this is hypotenuse. So by Pythagoras theorem, we can calculate it is under root of r square minus r square. So using the value of cos alpha here, we get q divided by 2 epsilon naught, it is 1 minus, then it is base divided by hypotenuse, so base is this divided by hypotenuse. So in this way we can calculate what is the electric flux passing through the ball, right? Now we have another case, what is the electric flux through the sphere due to a line charge, right? Here again I have taken two cases. The line charge is outside the sphere and the line charge is inside the sphere. So I have put it in this way, that for d greater than r, d is the distance from the center of the sphere to the line charge, and r is the radius of the sphere, okay? So when the line charge is outside the sphere, right, so the charge enclosed in the sphere by Gauss's theorem is 0, so the flux through the sphere is equal to 0. So we can write here phi is equal to 0 because charge is outside, right? Or we can say the number of field lines going into the sphere is number of field lines coming out of the sphere. So that is phi out minus phi in is equal to 0, or we can say phi out is equal to phi in, right? So this is the simplest case. Now, if I slide this linear charge distribution towards the sphere, so that the distance of the line charge from the center is less than the radius of the sphere, right? So when it is less than the radius of the sphere, that is for d less than r, line charge cuts the sphere. So it cuts the sphere here, so it goes into the sphere, right? Then what is the length of the linear charge distribution inside the sphere? So that is this much. I can name this as AB, or this can be calculated as since this is r, this is d, so this much distance will be equal under root of r square minus d square. So then AB is equal to 2 times root of r square minus d square, right? If this is the length of the linear charge inside the sphere, then the charge enclosed, if lambda is the linear charge density, so Q enclosed is lambda times L, so that is 2 times, L is this 2 times under root of r square minus d square times lambda. So thus by definition, phi is equal to Q enclosed divided by epsilon naught. So it is equal to 2 lambda under root of r square minus d square divided by epsilon naught. So this way we can calculate the electric flux through a